So what can you break 3x into? 3 and x, right? Because 3 is prime, and x can't be broken down because we don't know what it is. What can I break 9 into? Jada? 3 and 3, and those are both prime, right? Okay, so we're good with that. Now the only thing I'm going to change is now I'm going to write it as an addition sentence. So it's going to be 3x plus 9. And we're going to factor it, which means take out what they have in common. So what do we have in common? 3. So I'm going to take out the 3. Now, what am I left with on this first term? Cheyenne? Plus, what am I left with on this term? Hallie? 3. And this is my answer. Yes, Sean. No, you will use all of them. So if I have something like 4x minus 28, how can I break down 4x? And good. And then these would all be prime, right? How can I break down 28? Callie? 14 and 2. And then how can I break down 14? Cheyenne? 7 and 2. And then those are all prime now, right? Okay, so what do I have that's in common? Jada? 2. Okay, so I take out my 2's. And another set of 2's. So now I have 2 times 2 in common. So it's 2 times 2. So I'm going to pull out the 4, because I pulled out 2 pairs of 2's. And then what am I left with on this term? X. Minus what? That's not prime, so I don't use it. 7 is my only prime left, so that's what it would look like. I still didn't quite answer Sean's question. Questions on this? Now, sometimes you're going to get something like, let's do 15x plus I don't want to use 15x. I want to use 6x plus 4d. Okay, what can I break 6x into? 3 and 2. And then x, and those are all prime now. What can I break 40 into? 4 and 10. 4 becomes, those are prime. 10 becomes 5 and 2. So I've got all my prime numbers, right? What do I have that's in common, Julia? I just have the 2, so I'm going to cross off my 2's. Now, what am I left on this one? Jada? What? 3x, because I have 3 times x, plus, what do I have left on this one? Sean? Yes, we times them. So 2 times 5 would give me 10 times 2 would give me 20. So that is how you would do that one. Now you know that it's factored when my numbers inside my parentheses can have nothing in common. So I have 3 and 20. Is there anything that they have in common? No, so you know you're done. Yes, Ryan. So if this had a y term on it, so I don't have the y or the x in common, right? So yes, it would be y. I would leave the y with it. Yep, yes. So if this was, instead of making it a y, you're saying, what if that was an x? Okay, so then they have an x in common, right? So I would pull out the x, which means I would just have 3 left, and I would just have 20 left. Usually we won't see it quite like that, but sometimes. Does that make sense? So it's just what you have left for each term that goes there. So would you solve what's in parentheses? That's why there's usually an X there, because they wouldn't usually leave it like that. Yes.
Pretty sure last year at some point during math we were learning a little bit about variables.
Uh-huh.
And Mr. Rathbone said, I think he did. My brain might be taking a memory, but I think he said that normally you don't see X as a variable because it can be mistaken for multiplication.
Other way around. We don't usually see multiplication written with an X because X is a very common variable. So, like when you get into, remember when you graph, like on a coordinate plane, you have an X coordinate and a Y coordinate. That's why X is used all the time, because of the X coordinate. And you'll get more into that next year and then even more in algebra. Yep. Okay, so going back to this, what can I break 4 into? 2 and 2. What can I break 35 into? Do they have anything in common? So what's the answer?
You have to multiply them together.
It's just cannot be factored. Cannot be factored. If they don't have any common factors, you can't factor them. You can't take anything out of them. Does that make sense? Okay. I think that should be good for now. In